Plenty of people are thrilled about the idea of establishing cities on other worlds, and we get it. I mean, imagine looking at the sky and seeing Earth as a distant planet instead of Venus or Mars. But building a Mars city or a moon city is way easier said than done. Like, for one thing, there won't be any building materials readily available. We'd need to transport supplies or building equipment from Earth, and rockets and their fuel come at an astronomical price tag. So some researchers are proposing another idea: bringing a simple, lightweight material that could be used to grow structures on other worlds. And they're looking to fungi for help. As you walk through the forest or even your own yard, you're probably walking right above fungi. See, mushrooms are the reproductive part of some fungi, and they're just the tip of the iceberg. The main bodies of many fungi are found underground, and they're called mycelia. A mycelium is a network of fibers that creeps through the soil in search of food, and anything made of carbon and nitrogen will do. Because it's not very picky about what it eats, mycelium is cheap and easy to grow. It can even be grown on things that would otherwise be waste products, like sawdust and rice hulls, the hard, inedible outer coating of rice. And with the right conditions, researchers can turn mycelia into building materials. As it grows, the mycelium fibers invade and bond their food source to form a sort of composite, which can take all kinds of forms. Depending on how you grow and treat it, it might look like particle board, foams, or bricks. Then, once it's the right size and shape, the final material is baked to kill off the fungus, because otherwise, the organism would keep eating it. Mycelia-based products are lightweight, but are still as strong and flexible as lumber and reinforced concrete. And because it's fast-growing and requires few resources, mycelia are more sustainable than other materials made from once-living things, like timber. So far, at least one structure has already been built from mycelium bricks: the Hi-Fi installation in New York City. And now, NASA and the European Space Agency are working to take this idea off-world. There are two separate projects here: NASA's Myco-Architecture project and another from the European Space Agency's Advanced Concepts team. They're separately working on making living, growing building materials, ones that could be used to expand existing buildings, repair damage, and even process food and bodily waste from their inhabitants. Now, the big question here is if fungi could survive in space. The limited gravity, little to no atmosphere, and cell-damaging radiation are huge challenges for humans. So, would they be too much for fungi? Incredibly, the answer seems to be no. A number of fungi have been grown in space, and several have been almost completely unfazed by it. Like assorted fungi grown on the International Space Station have had no problem reproducing, despite the lack of gravity. Meanwhile, when it comes to studies on temperature and radiation, most of the research has focused on Mars, not the Moon. But it's still been promising. For instance, in one study, 2 species of Antarctic fungus were grown on the ISS under simulated Mars conditions for 18 months. The experiment simulated Mars's gravity, atmosphere, and radiation. And in the end, even though it didn't grow or reproduce as much of their DNA was still stable. In another study, radiation has even been found to enhance the growth of certain fungi with melanin in their tissues. Specifically, the melanin seems to be able to harness this energy to survive and grow. So growing the fungus in space might not be the problem. Instead, the issue might be coming up with enough resources to keep it alive long enough to form a structure. NASA's Myco-Architecture project presents a unique solution for this, though: a 3-layer dome. The outside layer would be made from water ice, harvested from reserves on Mars or the Moon. As the ice melts, maybe from something like sunlight or an artificial heat source, the water would trickle down to the second layer made out of cyanobacteria, a photosynthetic bacteria. Then the cyanobacteria would produce nutrients for the third and final layer of the structure, a flexible plastic shell embedded with mycelia. All these materials would be lightweight and cheaper to transport off Earth than existing building materials. Doing this would also be easier than bringing up huge equipment to try and build structures out of moon dust or Mars rocks, which some other teams have proposed. And really, using mycelia to build structures would just be the start. Researchers imagine imagine using the mycelia structures to filter water and extract useful minerals from waste products. And once they've reached the end of their life, these biomaterials could be recycled and turned into fertilizer for farming. This type of technology isn't just useful for other worlds either. With ever-increasing carbon emissions on Earth coming from new construction, there's a real need for more environmentally friendly building materials. So even if a Mars or Moon city is far off, this kind of research is still huge. Because while we're researching ways to live on other worlds, we might also discover more sustainable ways of living on our own. Thanks for watching this episode of SciShow Space. We love making videos about our surprising, knowable universe, and we can do it because of all the people on Patreon who support the show. If supporting this kind of free science education strikes a chord for you, you can go to patreon.com/SciShowSpace to learn more. And to all our current patrons, thank you.